Good morning, dear students. Last session, we have talked about the high strength concrete, its constituents, and their desired properties, limitations, if any. All that. I'll just quickly run through those slides. So we have talked about aggregates and the desired properties of aggregates, and the maximum size of coarse aggregate, how much it should be limited to, we have introduced in the last session. And cement, about cement, what sort of cement is to be chosen for a particular type of work that you are planning for pre-stressed concrete preparation, and what sort of water you should use for mixing in case of pre-stressed concrete preparation. Okay, uh, this is and admixtures. What are all admixtures are available for preparing the pre-stressed concrete? So we have talked about both chemical admixtures and also mineral admixtures. Okay. Right. Now we have come to the case of the properties of hardened concrete. We are talking about what properties you have for hardened concrete. Okay. So till now, what we have been talking about is to prepare pre-stressed concrete. What sort of materials we use? What are all different constituents we have to mix? Right. Now we will talk about the properties of hardened concrete. So the strength is the main criteria. So where why we need strength of concrete, that we have enlisted in the last session. Okay, right. So why we need strength for concrete is to sustain high stresses at anchorage regions. This is one such reason for high strength, and to have high resistance in compression, tension, shear, and bond. And the higher stiffness will reduce the deflection, and to have shrinkage cracks reduction is also one such reason for high strength concrete. Okay, so for normal PCC or RCC, we use the concrete M20 grade of concrete is generally preferred for usage. Whereas for the case of pre-stressed preparation of pre-stressed concrete member, we have talked about in the initial sessions itself that you need for the pre-stress to be induced in the member, we need to have a high strength concrete and high tensile steel. So this is the uh, foremost fundamental requirement. Okay, so let us come to one by one the compressive strength and tensile strength. Likewise, the strength properties of the concrete. Okay, so compressive strength of concrete, okay, is actually uh, measured in terms of a characteristic compressive strength of 150 size cube tested at 28 days, and that is called as FCK. So this you know very well from your previous lessons, like the concrete technology, or else RCC, design of reinforced concrete structures. Okay, right. So the diagram that you see here is the distribution diagram, normal distribution diagram for concrete strength. So on x-axis we take 28 days cube compressive strength, and on y-axis it is frequency. That means number of samples taken. Okay, right. So in general, what does this mean? That is, the not more than 5% of the samples that you have taken shall not fall below the mean strength of the concrete. This is what it means. So that if you take, for example, 100 samples for testing, uh, not more than 5 cube strengths values shall not fall below the mean value of those 100 cubes taken. Okay. So that is the nature of testing for compressive strength that we uh, talk about. So the compressive strength of concrete is given in terms of how do you convey the compressive strength of the concrete is by the characteristic compressive strength of a 150 size cube at 28 days, which is referred as FCK. Okay, right. So the table in clause 6.1, 9.2.2, and 21.1. So this table 1, in fact, gives you, this table 1 gives you the grades of concrete. Okay, what grades are available for preparation of pre-stressed concrete? Right. So this is taken from IS 1343 2012 table 1. Okay. Now you can see the minimum grade itself is M30, and its characteristic compressive strength at 28 days is 30 megapascal, 13 Newton per mm square. Okay. Now, the available grades of concrete. So beyond 30, you can go 35, 40, 45, 50, 55, 60, 65, 70, 75, and M80 grade also you can use. So earlier code like IS 1343 1980 gives you the grades only up to M60, and this is the modification in the recent code. Okay, so IS 1343 1980 uh, is will only give you the grades up to M60 only, right? These grades have been added later on. Okay, right, and the following points are also uh, note, in terms of note, are also important. Now in the designation of concrete mix, that M refers to the mix, and the number refers to compressive strength of 150 size cube at 28 days, expressed in Newton per square. So M30 grade of concrete means mix. M means mix. 30 means 30 Newton per square. If you prepare a cube of 150 size and test it at 28 days. Okay. Next, for pre-tensioned pre-stressed concrete, the grade of concrete shall not be less than M40. Okay. For pre-tensioned. For post-tensioned is M30. Okay, shall not be less than M30 for post-tensioned. So remember, M30 concrete and M40 concrete. These are the two grades of concretes that are much uh, specific need we have. So M30 is for post-tensioned pre-stressed concrete members. Post-tensioned means what? Uh, First you prepare a concrete member, then you insert the tendon, pull it and bolt it. That is what is called post-tension pre-stressed concrete member. Post-tension means after hardening of concrete, we tension the tendon. We pull the tendon. Okay? That is post-tension. Pre-tensioned means what? First you tension the tendon, then pour the concrete. Okay, once the concrete is gets hardened, then you cut the tendon. Okay, by proper timing. This is what is pre-tension, pre-stressed concrete. So for pre-tensioning, grade of concrete used shall not be less than 40 M40. The minimum grade of concrete. So I put it in terms of a question. What is the minimum grade of concrete which shall be used for pre-tension pre-stressed concrete? Likewise, the other question. What shall be the minimum grade of concrete which shall be used for pre-tensioned pre-stressed concrete and post-tension pre-stressed concrete? Okay, right. So come to third note given. Except where specifically mentioned otherwise for concrete grades greater than M60. Design parameters given in the particular standard may not be applicable. The values may be obtained from specialized literatures and experimental results. Okay, so this is the note. Except where specifically mentioned otherwise for concrete grades more than M60, the design parameters shall be obtained from either by reading proper literature over that or else experimental results you may rely upon. Okay, so this is about table 1. So table 1 of IS 1343 gives you the complete information about the grades of concrete for pre-stressed concrete members, and also what is a minimum grade of concrete to be used for the two types of pre-stressed concrete members. So one is pre-tension, other one is post-tension. Okay, right. I think I'm clear. Going for the next slide. And this is what I have given here as a gist from the last slide. So for post-tensioned members, M30 grade shall be used, and for pre-tension members, 40 M40 grade shall be used. Okay, minimum grade of concrete. Grade of concrete should not be less than that value. Okay. And as I said, for normal concrete, RCC or PCC, we go generally M20 and some specific cases maybe M25, not more than that. And the maximum grade of concrete which is specified by the code is M80. Okay. And anything beyond 60, M60, so wherever the data which is not available, as the code says, you shall refer to literature or you have to do your own experimental work and take those values, right? right? And the increase in strength with the age, which is given in this code, is not observed in present day concrete that gains almost 99.9% of the strength, substantial strength, which is for 28 days. Hence, the age factor, which is in clause 621, shall not be considered. So it is removed from IS 4562,000. Okay, the strength of the concrete after 28 days. If you want to calculate the strength of the concrete after 28 days, the age factor shall be neglected. Okay, so that is what this says. So increase, definitely strength increase it says, but it is not observed, which has no substantial change. Notable change is not there. Even if you test it at 28 days, maybe after 1 year, even if you test the concrete, the strength is not having much variation. Okay, so it is almost it is attaining the required strength in 28 days itself. That is what it says. So that is about compressive strength of the pre-stressed concrete. Uh, uh, the grades of concrete available. What exactly is compressive strength of the concrete, and what is the acceptability of concrete and criteria? Same as the RCC and PCC. The same acceptability criteria is here. 5% of the sample shall not have uh, the mean compressive strength of the cubes tested. Okay, so that is what is called acceptability criteria. Next, grades of concrete we have talked about, and the minimum grades required, the maximum grade available, and right. So that's about compressive strength of the concrete. Next, going for the tensile strength of the concrete. Generally, tensile strength of the concrete is negligible, very uh, minimum value. And if we say concrete is weak in tension, okay. So let us see what is tensile strength in of concrete. Okay. So either it has many ways of finding it. Whereas compressive strength is only by the cube compressive strength. Now, flexural tensile strength you can calculate, or splitting tensile strength you can calculate, or direct tensile strength also. It can be, uh, the tensile strength can be referred. Okay. So, what is flexural tensile strength and how do you find it? So, it is measured by testing beams. So you have to prepare beams of the required grade of concrete. So if you want for a grade of M30, what is its tensile strength if you want for M30 grade of concrete? What is the tensile strength if you want? You have to prepare a beam of some standard size under 2-point loading, also called 4-point loading, including reactions. Means what? You have to take the loading like this. Okay. Then if you find the tensile strength of this concrete, where this concrete member is failed, okay, by bending, pure bending, that is what is called flexural tensile strength. Likewise, so you have to take it by testing by measurement. Split tensile strength. It is measured by testing cylinders under diametral compression. So, 150 mm dia, 300 mm height, cylindrical molds you have. So, you have to prepare a cylindrical mold of concrete, of required grade of concrete, and then test it under diametral compression. You have to apply the compressive load to this specimen and find the tensile strength. That is what is called splitting tensile strength or split tensile strength. Okay, so these two, the second one we will be doing extensively in our laboratory, and uh, the flexural tensile strength sometimes by a PG student, uh, maybe a scholar, research scholar, sometimes, rarely by a UG student, flexural tensile strength. Okay, so this is very common. Split tensile strength is very common. Now, what is direct tensile strength? Directly by applying tensile force onto a rectangular specimen under direct tension is called direct tensile strength. So this is still in research mode. So where you prepare one member, okay, you put it in UTM and pull it, apply tensile force. So wherever you observe that it is going to fail, that it takes maximum load by a cross-sectional area, that is what is tensile strength. That is called direct tensile strength. So there are three forms of tensile strengths for concrete. One very well known to you is split tensile strength, which you come across in your undergraduate study. Flexural tensile strength, very common for PG students for their dissertation works and all they carry out. Okay, and for UG student, we'll just demonstrate that. And direct tensile strength is still, many of the researchers are finding their own ways of doing such tests because, uh, to pull the concrete block, uh, you don't have a direct setup. UTM, you have the setup for pulling the rod, the reinforcing bar, but not the concrete. So you have to devise your own test setup for that, then do your research and present your result like this. Right. If in case of absence of test results, the code recommends to use by a simple formula of flexural tensile strength from compressive strength, because compressive strength, flexural strength is related to compressive strength. If the compressive strength is high, flexural strength is high. If compressive strength is low, flexural strength is also low. Okay, so FCR is the uh, notation for flexural strength. FCR, flexural tensile strength. Uh, that is by a simple relation, 0.7 times root FCK. Okay, so this is how we find flexural tensile strength. Okay, so if you know compressive strength value, you can straight away flexural tensile strength can be found out. Okay, so this is how we get the flexural tensile strength value. Okay, now stiffness of the concrete. Okay, we'll talk about this in the further sessions. Okay. Thank you.